The original process. Early chemists worked in simple benchtop laboratories with glassware, balancers, sealed flasks, and basic burners. Glass reaction flasks, mercury manometers, sealed gas bulbs, and water displacement containers and mechanical balancers. And one of the early classic ways to determine Avogadro's numbers was through silver plating via electroisms. Original difficulties. Maxwell was trying to unify electricity, magnetisms, and light into a single mathematic framework. But experimental data at that time was incomplete. Early electrical experiments involved exposed conductive wiring, unstable chemical batteries, and variable manual current sources. Maxwell had to devise relationship symbolizing because there were no calculators and no digital data storage. Original motivations. No benefits. Original benefits of science gas calculations with much higher accuracy. Like basic calculations, you can't use to verify an open pathway for future materials, research, particles behavior, and math. The modern process. Temperature, pressure, and humidity are maintained by computer automation to reduce error in gas behavior measurements. Ultra-accurate sensors and digital data capture devices now replace manual glass measurements and eyeballing techniques. Data is stored instantly in the cloud database and analyzed with AI modeling, statistics software, and automatic mathematician solvers. Certain differences. Modern research now use automatic mathematical solvers plus quantum level models. Instead of depending mainly on theological equations like Maxwell did, strict OSHA and EPA lab regulations now exist to protect scientists, unlike back in Maxwell's time, where most workers had almost no safety standards at all. Expectations. Future scientists will focus on pushing molecular measurements accuracy into the quantum scales to directly count extremely small particle populations instead of estimating them. Healthcare and pharmaceutical companies may be able to produce personalized molecular